Hi again. So previously we looked at a question that talks about apples and bananas, and now we reach question 4, which is relating to that question. It says, suppose the person faced with the budget constraint described in problem 2.1, it actually talks about problem 3, has a preference for apples and bananas given by utility equals the square root of A times B. And part A says, if A equals to 5, so if the number of apples equals to 5 and the number of bananas equals to 80, what will the utility be? So let's calculate that. We know the function for utility is equal to the square root of A times B. And we know that the number of apples is equal to 5 and the number of bananas is equal to 80. So utility should equal to the square root of 5 times 80. So this is equal to the square root of 400, and therefore utility should equal to 20. The amount of utility gained from acquiring 5 apples and 80 bananas is 20 utils. Next question. Part B says, if A is equal to 10, what value for B will provide the same utility as in part A? So recall in part A we have U is equal to 20. So the amount of utility is equal to 20. We also know that U is equal to the square root of A times B, and it's saying that the value for A is 10. So this is equal to the square root of 10 times B, and we know that this should be equal to 20 because we want the same value of utility as in part A. So 20 is equal to the square root of 10 times B. Now to get rid of this square root sign, we will square both sides. So 20 squared is equal to 10 times B. So 400 is equal to 10 times B. Therefore, B is equal to 400 divided by 10, which is equal to 40 bananas. So if you have 40 bananas and 10 apples, you would have the same utility as in part A, where you had 80 bananas and 5 apples. Part C says, if A is equal to 20, what value for B will provide the same utility as in part A and B? So again, we're trying to achieve a utility of 20 utils. So again, we'll try the same method. 20 now must equal to the square root of A times B, which is equal to the square root of 20 times B. We'll square both sides to get rid of the square root sign. So 20 squared is equal to 20 times B. Therefore, 400 is equal to 20 times the number of bananas. Therefore, in conclusion, the number of bananas should be 400 divided by 20, which is only equal to 20 bananas. This answers part C of the question. Part D says to graph the indifference curve implied by part A through C. Now we'll come back to this because the last part of question 4 also asks for a graph. Part E says, given the budget constraint from problem 2.1, again they're talking about question 3 which we just completed, which of the points identified in part A through C can be bought by this person? If we call the budget constraint was $8 equals 0.4A plus 0.1B. So this was our budget constraint, and they want to know which of these points that we calculated between part A to C can be bought given this budget constraint. In part A, we had 5 apples and 80 bananas. If you have 5 apples, it will be 0.4 times 5 plus 80 bananas, 0.1 times 80. This should give you a value of 10. Now, our budget constraint is $8, so we cannot buy 5 apples and 80 bananas given our budget constraint. Let's check part B. Part B had 10 apples and 40 bananas. And if you calculate this, you should get $8. So we could purchase part B given our budget constraint. Now if you look at part C, where there are 20 apples and 20 bananas, this again is equal to 10. So we cannot purchase the combination in part C. So basically, with this question which asks which combination can be bought, we can only purchase 10 apples and 40 bananas. Only part B, only that combination can be bought given our budget constraint described in question 3. Part F says, show through some examples that every other way of allocating income provides less utility than does the points identified in Part B. Graph this utility maximizing situation. So we just need to show a few points. We could show one above, one below, and the two extreme points, and we would see if it indeed gives less utility than that described in Part B. Again, in Part B we had the utility was equal to 20, and in Part B, to get this utility, we had 10 apples and 40 bananas. Let's try one less apple. The utility would have to be for 9 apples and 44 bananas, because as we calculated in Part C, if it's 40 cents for one apple and 10 cents for one banana, then if you have one less apple, you could purchase 4 more bananas. So if you have one less apple, so the apple is now 9, now we could purchase 44 bananas. And if you calculate this, you should get the square root of 396, which is less than the square root of 400. So overall, this is less than 20. And let's try one more apple. So this will be the utility of 11 apples, and we have to multiply this by 36, because if you purchase one more apple, which is 40 cents, you now have to purchase 4 less bananas. And again, you would get the square root of 396, which is less than the square root of 400. And the square root of 400 is equal to 20, right? So overall, this would be less than 20. Let's look at the two endpoints, the two extremes, where you purchase all apples or all bananas. Let's try all apples. The utility would be the square root of 20 times, if you spend all your income on apples, therefore, and you buy no bananas, you would have a utility of 0. If you buy all bananas, so if you spend all your income on bananas, then your utility should be 0 apples times 80 bananas. Your utility again would be 0. So this basically proves that any point other than that described in Part B, you will have less utility. And the last part of this question asks to graph the utility maximizing solution. And this is why I skipped Part D before, because we will draw everything in one graph. And this is the graph that you are asked to draw here. So this here is your indifference curve, and this here is your budget constraint. This point here, where the budget constraint is tangential to your indifference curve, that is your utility maximizing point, which was the same combination that we calculated in Part B, with 40 bananas and 10 apples. And that's it for this question. Thank you for watching, and I'll see you in the next one. Goodbye.